Welcome back to Infinity Beyond, where tonight we become time travelers of stone. In our journey through the frozen annals of Earth's history, we've envisioned an entire world wrapped in ice and pondered how life clung to survival beneath the frost. But now we ask, how do we know this actually happened? Where is the proof that Snowball Earth wasn't just a poetic metaphor, but a brutal, planetary reality? As it turns out, the evidence lies not in frozen glaciers or preserved fossils, but in rocks, silent witnesses to Earth's most dramatic eras. Let's begin in Namibia, Africa. There, geologists discovered layers of glacial deposits, rocks scraped and tumbled by ice sheets, preserved in ancient sedimentary basins. These rocks date back over 700 million years. What's astonishing is not just their age, but their location. These glacial deposits were found in what would have been tropical latitudes at the time. That's like finding evidence of an ancient blizzard in modern-day Brazil. How is that possible? It suggests that glaciers, traditionally confined to polar regions, once reached all the way to the equator. This alone was enough to rattle the foundations of geoscience. But that was just the beginning. Further north in Canada, dropstones were unearthed, large, heavy rocks embedded in fine oceanic mudstone. These could only have arrived via icebergs, giant floating blocks of ice that carried stones from the continents into the open sea. As the icebergs melted, the stones dropped into the sediment, forming what are now called glacial dropstones. Again, these were found in formations believed to be near the equator during the Cryogenian period. Geologists also turned their gaze to isotopes, variations of elements that behave like fingerprints in the rock record. During Snowball Earth events, carbon isotope ratios in marine sediments shifted dramatically, indicating a disruption in the global carbon cycle. These patterns, abrupt changes followed by long periods of stability, are consistent across multiple continents, implying a global event rather than a regional freeze. And then came the cap carbonates. These are unusual limestone layers that sit directly above glacial deposits. They are smooth, light-colored, and rich in carbonate minerals. What's fascinating is that they formed rapidly, and only after the ice melted. Why? Because during Snowball Earth, volcanic CO2 had accumulated in the atmosphere unchecked for millions of years. There were no rainforests or weathering to scrub it out. When Earth finally thawed, this massive CO2 concentration caused extreme greenhouse conditions. Rainfall became acidic, oceans absorbed the carbon, and vast carbonate platforms were laid down like a planetary signature, marking the end of each Snowball episode. These cap carbonates are found worldwide, from Australia to China, from Africa to North America, always on top of glacial layers, always in the same sequence. Even more astonishing is that in some of these ancient formations, we find tiny ripples, frozen records of waves that once lapped against open water. But how did open water exist during a global freeze? It's likely that cracks formed in the ice, or that melting began unevenly, giving way to short-lived thawing phases before the full meltdown took over. And then there's paleomagnetism. By examining the magnetic minerals in rocks, scientists can determine where those rocks were located on the Earth when they formed. In Snowball Earth-era rocks, the evidence is clear. The glacial deposits occurred at low latitudes, not near the poles. This supports the idea that glaciation extended globally, encasing even the warmest regions of the planet in ice. Taken together, this global jigsaw puzzle of evidence forms a consistent, powerful narrative. Not only did Earth freeze over once, but possibly multiple times during the Precambrian. Two major Snowball Earth events are widely recognized. The Sturtian glaciation, about 717 to 659 million years ago, and the Marinoan glaciation, about 650 to 635 million years ago. And yet, It's still a mystery. Some scientists argue for a slush ball Earth instead, a world where the tropics remained partially open while polar regions were frozen. Others raise questions about the precise timing, duration, and severity. Debate is natural in science, but the overwhelming body of data supports the existence of one or more near-global glaciations, a frozen planet, revived by time and heat. This search for ancient climate clues is not just about the past. It's a mirror for the future. If Earth could experience such dramatic climate swings, from icehouse to greenhouse, it reminds us how dynamic and fragile planetary systems truly are. Studying Snowball Earth helps climatologists understand runaway feedback loops, like those triggered by melting polar ice or carbon emissions today. It offers context for the tipping points we now face. So the next time you see a rock, weathered, cracked, sun-bleached, remember, it might be holding secrets from a time when Earth was an ice world, a time when silence ruled and the sky was a mirror of cold. In the next episode of Infinity Beyond, we'll explore what happened after the thaw, the violent return of warmth, the rise of complex life, and how this great freeze may have set the stage for evolution as we know it. Until then, keep your curiosity sharp and your mind open. The rocks beneath your feet may be telling the oldest story ever told.